Okay, let me put on battery saver and then, okay, now it's recording. So let's start. So this is part 0. We're gonna start with um, we're gonna start with the intensive revision, right? So convolutions, right? The university, okay, let me try to zoom in. The University of Johannesburg. I think that's how
Wena
Afrikaners say it.
gan
Your Johannesburg needs you to create a data structure called UJ image containing a two-dimensional array of structures representing the pixel. And then a single pixel for the image is defined as follows. This one is a bit tricky. You need to follow the instructions. So you see that they said create a UJ image, which is a data structure. So there's multiple data structures, right? There's plenty of data structures. We have a record structure, which can be a data structure, which can represent a data structure, and we can
Mhm,
have a class, and we can have an array. Yeah, so there's multiple data structures that we can use. So we need to find out which one is more applicable here. You see that this data structure called UJ image, at this point in time, we don't know what UJ image is. Is it a record structure? Is it a class? Is it a what? We don't know yet.
mm,
And then it contains a two-dimensional array of
structure.
structures.
Mm,
You see, structures. That means we need to create a record structure and then create two pointers of that type of that record structure.
mm,
So they said a single pixel for a grayscale image is defined as follows. So a single pixel. That
mm,
means the record structure that I'm going to create should be called pixel or UJ pixel, but pixel because they said for a single pixel, this is the data. So I see that that's pretty much what they're talking about. And then I'm going to scroll a bit down. So this part will always be there, but then skip this part because it just explains instructions on what to do. And then T design, and then yeah. So now we can tell here, he says you must create a class to represent UJ image. So we now know the data structure that must be used there is UJ. What that must be created is UJ image. So now since now we know that means UJ image is a class, and you see that UJ image is an image type. And what I would do is for my enums, right, I'm gonna name them exactly the way it's given here. Even the capitalization, I'll call it this, and then the names within the enum, yeah. So we'll get to that one at a time, right? So let me not talk too much and open code block so that we start. So it's CSC 01 2023 ST2A MEMO. So I'm gonna name it in that way too. So put this a bit down and then create a new project. And then next. Then CSC 01 B1 2023. And then this was a semester test 2 paper, and then it was paper A. And then this is the memo for it. So I'm gonna name it in that way, and then there we go. So what I will do is I'll show you how you go about changing your file, right? Because remember bonus, how bonus works. So if you scroll down, because I want you to, yeah. So see descriptions of following page, whatever. Only one bonus may be attempted. And the bonus is 20%. So if you manage to get 100% on the normal code without the bonus, you will get 120%, right? But they'll cap it to 100. That's why they're telling you this node. I mean, the maximum you can get is 100%. It's just for you to show them, okay, I mean, I'm goated, I'm built different. I'll do what you've required, and I'll also do extra, which is the bonus. And
mm,
comments alone, there's 2%. So these are free marks. And then if you use header file and CPP files, there's also 3% on that. So by default, you have 5% if you just do the normal structure that we've been doing. And then for design, I don't see where design. Yeah, UML has 10%. So basically you have 15% for free before you like actually implement anything. So if you do the design and you create your header files, all of them .h, uj.image.h, ujimage.cpp, all of them, and the inheritance class, the child classes, all of them, you created the individual h.h files and cpp files, you already have 15% with no code in them. So that's pretty, it's easy to pass this test. So you must select ones, and you must read carefully what each one is requiring you to do. So let's look at the exception hand, the templates. Make the entire UJ class templated, and every member function must be implemented as a templated function. So basically make UJ image a template class. So it's fine. I'll do that. But what I would do is I'll show you how to change. Actually, they always tell you to start solving the problem first. Don't just immediately go into the bonus, because if I'm not mistaken, okay, I don't know. I don't see whereby they say you must submit separate. Yeah, there is. The bonus must be submitted as a separate submission. So what I advise you to do, make sure you solve everything and do the design and do everything. Once you're done, you see that it's small changes to do the bonus. It's going to be small changes. Then once you've zipped and uploaded that the normal code, then you can start working on the bonus. And remember, if you as long as you upload twice and it's two different names, then it's going to be two different submissions. So you're gonna name how your project should be named. Then for the bonus, you're just gonna rename and at the end you're gonna put underscore bonus to show that this is a bonus file. So that's how you're gonna submit. So let's see UJ image. It contains a two-dimensional array of structures. So I know that I'm going to have a UJ image. So let's start there. So I'm going to say file and then new file. Like enough, there's no double indexing that one where you create UJ row. Or else, it wasn't going to end well. So UJ image.h. And then I'm going to save it to then my current project folder and remove underscore included. Out of a habit, you don't have to remove it. And then apply. And then there's my header file. And then I'm going to create another file. So remember, we haven't applied bonus yet, so I shouldn't create an imp file. Like I said, start solving the actual problem. So source file, and then I'm going to call it uj image.cpp. And then save, and then all, because you need to be able to debug. If you don't press all here, it's not going to show you errors. Don't forget to select all. And then I know I need to include UJ image. Yeah. Then now let's define the class, right? So class UJ image. So this is our class. So this is our class. So let me go back to my project. But before the class, you see everything is order. Look at the what is supposed to be inside the class. Remember, they said the class should have a two-dimensional array of structures. And they said a single pixel. And you need to understand the English here. A dynamic, meaning that it's pointers, two-dimensional array of structures representing pixels. So that means each pixel is represented using a record structure. Then they continuously describe what a single pixel will have. Basically, what information should go within that structure. A single pixel for a grayscale. So we're dealing with a grayscale image, meaning P2. So it's a single pixel for a grayscale image is defined as follows. We have image type, which is an enum. So let's do it in that order. They said image type, which is an enum. So I'm going to go here and say and create an enum for image. type. C++ is nice, Shem. My favorite language. So enum, I'm gonna call it exactly how it's named there, image type, like this, right? And then there's two types. There's grayscale or edge. So you could name it exactly this way, but then remember in enum, we're basically naming, we are giving all these constants a name. We are basically like grouping common constants that represent one thing. So when you see me right here, gray, that's why we're going to use grayscale. So that's why you're going to see me doing it this way in uppercase letters. Why? Because if you remember how to rename constants, you say const followed by the data type here, right? Data type here, space followed by the name of the constant, and constants should be named in all caps in uppercase letters. So if you wanted to say number of rows, you say number. And if there's more than one word, you separate each word with an underscore. So number is one word. Of is another word. Rows is another word. So number of rows. You see, it's easy to read. But sometimes you define many constants over and over, which becomes, so you have something like this. You see, it becomes unnecessary. Now I have to keep typing const data. I don't have to keep doing that. What I'm going to do is I'm going to put it within an enum. By default, the data type is going to be int. So all of these are constant integers by default. That's how an enum works. All of them are integers. And the first one is given the value 0. And then every constant that follows, it's incremented by 1. And you can set its starting value, the first constant, and say, okay, let's make it start at -1. You can do that. That means every consecutive constant will be incremented by 1. So there's grayscale and edge, right? So that means edge would be the previous constant, which is grayscale. What is its value? -1 plus 1, which means its edge will be 0. So that means this will be 0. But I really don't care about whether it's negative or whatever. Not gonna put the, I'm not gonna initialize it to some starting value. So it will just have default value. So this will be a 0, this will be a 1, because it increases by 1. So so let me, because now my code is, okay, it's fine. Let me put what values it will have. So I have image type, there's grayscale and edge. So that's done. I've created my enum. This will be indicating how the image will be manipulated during drawing. So it just indicates how the image will be manipulated. And then we're going to have a red color component, integer indicating the red color component. So it's grayscale, but this is weird. Let me think. Grayscale. Oh, there's different ranges, yeah, for grayscale. We still have red, green, and blue. Let me just double check. So let me open and say P2 image Wikipedia. Okay, let me say gray scale image Wikipedia. Um, what is that? What is that website called again? The one where you see everything. It's PPM, right? Let me say PP or PGM. Wikipedia. Hopefully it is gonna show proper now. Where gonna go on? What's that website called? NetPBM. Yeah, this one. This is where we see all of them. Yeah, so you see a portable gray map or a grayscale image is a P2. You see, it's a P2 and it ends in PGM. It has 0 to 255, right? Um, color ranges, right? But then the 255 is the maximum, which should be black, if I'm not mistaken. No, it's gray. No, it's gray. And then 0 is the minimum intensity or the smallest number, which will represent black. The darkest shade, which is black because it's a grayscale image. So you see a P2 image here, you can remember you can use any range. Here they're using 15 as the maximum. We'll use the 255 or whatever the practical says. But if you notice something, I don't know why they're using 3 color components, because if you notice something here, each is if you notice something here, it's integers. It's not like an RGB. RGB is called RGB because there's red, green, and blue. So I don't know why they did it this way for this practical, but we're just gonna go with that convention. So they use red, green, and blue to represent the grayscale image. So all of them is red, green, and blue. And I like to use the normal types, right? Okay, so let's look at it. Let's see now. So remember, this red, green, and blue are part of what structure? The structure that represents a single pixel. So now it's time for me to create the structure. So this will be the structure. So struct, I'm gonna call it, I can call it UJ pixel. Let me call it UJ pixel. It represents my pixel. And then I'm going to say, I'm gonna use unsigned short. I want to save memory. So unsigned short, and I'm gonna say this is my red color component. And then right before I show the other colors, remember we have an enum, which represents the image type. It's called image type because that's what I've called it here. The enum is called image type, and the enum is within the struct. So image type, and I'm gonna say this is the type of image, or you can say type of image like this. That's up to you. But this is too long. I'm just gonna say type. And then I'm going to have all the other ones unsigned short, green, unsigned short, blue. So we have all the different colors, right? So we have our record structure. So far, let me see, there is marks for these things, man. So like I said, if you had done the header files and everything, that's 15, and the design, that's 15%. And then there is marks for the structure here. I forgot where, I don't see it, but it is, I don't know how exactly how many marks they're gonna allocate. I guess they're gonna allocate it when they look at your classes, when they see that you've created the class. So I'm gonna go back to here. So this represents a pixel, and all of this information is within the structure, right? Remember, because they said this is for a single pixel. It takes an image type, which is an enum on its own, and then we have the actual pixels, right? So I'm not sure what the range is, but I think we remember we're gonna read from the file. So we just have to read from the file, the image. But then I don't have the file. So we're just going to insert our own values. If only I had the files, the additional files, then yeah, it was going to be easy to read to see the image. So every pixel value will be set to a fixed value at startup. Remember, means you're gonna need to initialize, basically setting every pixel to 0. That's where your constructors come into place. Once done, a read file method will read all the pixels from a text file. You see, we just have to read the pixels from the text file. And then when a UJ image object is created, a record structure specifying the default pixel must be also provided in the parameterized construct. So that means when you create our UJ image, we must have a constructor that takes in a default pixel. So you see, it's really quite a lot you need to quite a lot to unpack. You need to read step by step. The image type of the record structure must be used to determine what kind of filter to be created by the image. So you must use this image type. Don't just leave it there. They want you to use it to determine what type of image to create. I'm sure in the file it does specify. So remember this part, right? This is just explaining all the files and the things that are needed, instructions. We don't need that. We need this part that talks about classes. In order to meet the requirements of this task, the project manager has broken the overall problem into several subtasks. See accompanying mark sheet for more details. So the design, that's easy to do, and follow instructions. It must be saved in a PDF file. You save it in a docx or Microsoft Word, that's an automatic 0 because they can't view your file. That would be a 0. So make sure you put it in the right format. Follow instructions. Class basics. You must create the class to represent UJ image. The class must make use of principles of good design known to you. What do they mean by that? Constructor, distractor, copy constructor, all of those, excluding the operator overloading. They haven't told you yet. They're just saying good design known to you. But if you notice something, I hope you did notice. No matter what you do, what practical you write or what test you write, there's always the assignment. That's important. It's always there. So just keep that in mind. So I'm gonna go back there. So I'm gonna create the UJ image, and it must additionally make use of a dynamic two-dimensional array of structures to store the pixel data. So they didn't give us much information yet. So that means we're just going off intuition. But if you check the previous year, it talked about a lot of things here. Whatever you do, you must have at least a constructor that takes in. Oh, let me see. When a UJ object is created, a record structure specifying the default value pixel must be also provided in the parameterized constructor. Oh, so they say a record structure specifying the default pixel. So we need to pass a whole pixel, a UJ pixel, right? Which is the whole record structure. No matter how many constructors you have, at least you should have that one because that one is going to have marks. The one they asked you to have. So public. So what I would do is I have three types of constructors, right? I'll have the no args one and then the parameterized one. Remember, I like to use unsigned short. So I'm gonna have, and remember, if you insert a header file, you don't need to give your parameters names, right? To say this is rows or whatever, because you're not coding it. You can just pass in the types. That's enough information for it to know. So unsigned short. And then the third one is the one that takes everything, which is the rows, columns, and the default pixel. So unsigned short, unsigned short, and then UJ pixel. And then this will be default pixel. Or you can just call it pixel, but I like to give my code meaning. So default pixel, right? And then we have the three types of constructors, as I said. We have the no args. We have the one that is only the size of the image. And then we have the one that is all three, the full one, which is the size, dimension, and the default pixel. And then let's not forget the copy constructor, because they said use good design principles known to you. They taught make use of principles of good design known to you. They taught you about copy constructors. So const uj image by reference, because we want to copy the image. So we don't want it to be lightweight. So we're going to take in a UJ image by reference. But since there's a possibility of changing the image, I'm going to put the const keyword to say it should remain constant, to leave it the way you found it. And then at the end of the day, I'm going to have a destructor, right? And then I'm going to have my private member variables. So I'm going to have the two, which is unsigned short underscore rows underscore columns. And then I'm going to have my pixel. Remember, they told you that this is about pixels, right? And remember, they said it's dynamically allocated two-dimensional array of pixels. So that means I must have two pointers because it's going to be 2D. So far we have this, but I know we're going to do operator overloading. I need to create all those helper methods for constructor, for copying the data, for deleting. So I'm going to have void constructor. And this one will take in all of them, right? When you create helper method, you always create a helper method that matches the constructor that takes in the full parameters. So you see this one is the one that takes in the full parameters. And then I called it constructor because I need to remember that this is code for my constructor. And then I like to keep things simple, Sham. And then for the helper method for the copy constructor, I will literally call it copy constructor. Copy constructor, right? And then this is a copy constructor. That means it takes in a const UJ image by reference. And then the last one is destructor. Remember when you use code more than once, you need to create a helper method so that you don't repeat yourself. So far this is the class that we have, but remember we have a default constructor here, which doesn't have any of the three. So that means you need to have three constants. So static const int, okay, not const int because I've used unsigned short, so it's const unsigned short for me. For you, you could use int, whatever type you feel comfortable with. So const unsigned short, and then I'm going to call it default underscore rows. Then the default rows just say 500 by 500, and then static const unsigned short default underscore calls is equals to 500 again. And then the last one is the pixel, right? The constant pixel. Remember, you use const only if the value on the right hand side of the equal sign is a single value or just an integer. Remember, unsigned short in full, it's unsigned short int. It's still an integer. And then long is also long int in full. Long is long int in full. So for those ones, if it's an integer, then you may use a const. But then if it has more than one value, like a double. Remember for a double, you have the quotient and the remainder, so it's more than one value. You would have to use const expression because it's now a whole expression. And for a double, remember, use the dot. There's a special symbol now, so it's now an expression. So the same applies with the record structure ejpixel. Why? Look at these values. How many values do I have? 4, which is more than one. So therefore, I'm going to use const expression, and then this will be uj pixel, and then this will be called default pixel is equals to, don't forget one important thing here. We have an image type. You must specify the image type. So by default, it should be a grayscale image. So I'm going to pass that there. Gray. How did I spell gray? Did I spell gray properly? Is this how you spell gray? I don't think this is how you spell gray. If I'm not mistaken, I think it's Grey. And then I want to say gray um, scale. By default, it's going to be a grayscale image, right? And then we need to pass in the red, green, and blue color component. If it's gray, remember we said this is a P2 image. That means when it's the maximum 255, that means it's going to be gray. So I'm going to say 255 for each. So instead of being white, it's going to be gray because it's a grayscale image. So I'm going to pass uh, 3 255s. So we have our constant there. And then just in case, because they said use proper what design known to you, right? In the future, I don't want to have to make there's so many changes right into my class. I'll create both accessors and mutators for everything, right? For my rows, columns, and pixel. So I'm gonna create accessors. I don't think the thing is you'll never know I don't want you to keep going back and forth to check, okay, should this class call that method from UJ image? Should I be able to access and set? But if you look at it, you see there's a lot of setting and changing and accessing. So that's why they told you here, make use of principles of good design known to you. To avoid all of those things, I would just by default put it there. So, okay, let me try to put my comments in a proper manner. So I'm going to say these are my accessors, and then these are my class constants, right? And then these are my constructors. You see, it looks proper now. And then let's do my accessors. Remember, my data type for the rows is unsigned short. So the return type for this function is unsigned short. And then it's going to be called get rows. And remember, it shouldn't change the rows. You should only just get them. So I'm going to append a const at the end to say whatever code is written within this function should be in constant form, meaning that it shouldn't affect my code. And then unsigned short get calls, and then const again. Every accessor needs to have a const at the end. And then short get pixel. You can call it UJ pixel, whatever you want to call it. So const, and then this should take in two values, right? Remember, we're accessing a pixel, and each pixel it's in a Cartesian plane. Remember, it's a coordinate system. It's row, column, right? That's how you get a pixel. Hence, it's 2D. It's like a Cartesian plane. So therefore, if I'm getting the pixel, I need to get passing two values. What row and what column am I retrieving this pixel from? So unsigned short again, twice unsigned short, because I need to take in a row and a column to go to my 2D array and get that specific pixel. And remember what I said, inside the header file, you do not have to give your parameters names. You can just only pass the type. That's enough. But when you go to the implementation file, you are implementing. You want to be able to access those parameters, those values of those parameters. So you're gonna have to give the parameters names. So this will be my mutators, which is basically setters. And then my accessors is basically getters. So now we're gonna have our getters and setters. So we should be able to change the rows, right? But then, okay, let me think about it. Should you be able to set the rows? I feel like in our case, right, you don't have to, but you can put it. But I don't think there's a point whereby they say change the image size. I've never seen that being asked. So the only mutator that we're gonna have is set pixel because I know I'm gonna have composition, inheritance, which is changing the pixel, manipulating the pixels, drawing and all those things. So I'm mutating the pixels, right? So that means I need to have a mutator, which is void set pixel, which takes in three parameters. It takes in what row and what column are you going to set the pixel for, and then what's the value of that pixel you are setting in? What value are you going to set it to? So UJ pixel. So it's three things. And I shouldn't put const there at the end because this is meant to set or mutate or change the data. And then I'm going to have here, I'm going to have this will be my distractor. There's always one distractor, so distractor. And then I know it's a bit far-fetched, right? It's a bit too much to do all at once. You could just skip anything that doesn't relate to the information you need to put inside the UJ image. For example, a class has a pixel painter, blah, blah, blah. It's up to you, you could put that because it has a pixel painter. But you see Pixel Painter, that means I need to create that header file and that CPP file and whatnot. So I'm not gonna do that yet. I'm just gonna go to the part where we need certain methods or what is this? What's the thing? Operator overloading. That's the things that I need. So let's look at it here. They said the pixel, what is the which implements the draw string value returning. Okay, so let's just implement it. I guess I have no choice. So before you start implementing, just add everything within your UJ image class so that you know it's complete. All you have to do is just implement everything. So your UJ image class has a pixel, paint has a composition or aggregation, one of those, which implements the draw method, draw string value returning. When they say value returning, it means that it returns that value. But what value does it return? A string. So this draw function should return a string. We'll fix that just now. But one thing at a time. It has a pixel painter. Let's start with that. I do not know whether it's composition or aggregation, so I won't put the pointer yet. I'm just going to say pixel painter underscore painter, right? That's it. I don't know whether it's composition or aggregation, so I won't paint yet. I won't put a point. I'm just gonna leave it like this. But then pixel painter is not UJ image doesn't know what it is. So you need to do a forward declaration. Why are we doing a forward declaration? Because I'm not gonna call any methods within pixel painter. I just wanted to stop shouting at me and saying, okay, pixel painter is not a defined type, blah, blah, blah. I'm just going to create a class, an empty class called pixel painter. And then when I go to ujimage.cpp, I'm going to need to include the pixel painter header file, which contains the implementation, the methods within the class. Because remember, in ujimage.cpp, we call the methods from that class. So before I continue, let me just create the empty files, the header file and the CPP file for both for the Pixel Painter, so that I know I don't have to go back to it. Pixelpainter.h. Remember, I haven't implemented anything yet. All I'm doing is just implementing my UJ image, but I noticed that it needs a Pixel Painter, so I'm forced to create the header file and CPP file for the Pixel Painter. And then double click on source file. Remember, we haven't done temp bonus yet. We're just pretending like the bonus does not exist. So pixel painter.cpp, select all, and then finish. And then within the pixel painter.cpp, I include pixel painter.h. And then that means we need to have a class called pixel painter, right? But before we do that, it's fine. We'll leave that for now. So this will be forward declaration, right? That's the forward declaration. And then I'm gonna go back to my file and read continuously and see what is Pixel Painter all about. Does UJ image manage its life cycle? When they tell you UJ image manages its life cycle, that means there's a life cycle dependency, meaning that one cannot live without the existence of the other, meaning that that's composition. But if they don't tell you that it manages its life cycle, then it's aggregation, meaning that you won't put a pointer because you're not managing its memory. So you won't need a pointer for that. You're not managing its memory, which implements the draw method value returning string. So there's a draw method that returns a string. So that means this method needs to be declared within UJ image because this is where we're gonna do delegation. But before I do that, I need to read continuously and see what's going on. Method that will not set the pixel attributes of the image, but rather generate a string with the new values. So it won't set the pixel image, the values for my pixel, but it will just generate a string with the new values. The UJ image delegates its own draw method to the contain pixel painter. Yeah, then there's this part. The UJ image class must manage the life cycle of pixel painter object. Therefore, pixel painter is now composition, right? It's now contained since the lifecycle is managed by UJ image. And they said it's the UJ image draw method should delegate its own method to Pixel Painter. And they didn't talk about parameters here, right? They didn't say UJ draw method, the draw method within UJ image should take this and that. They didn't tell you. So now I need to fix two things. I need to put a pointer there because now it's now composition, because we've been told that it manages its life cycle. So composition, right? And then I don't know about the set pixel because apparently it doesn't look like we're setting any pixel, but it's fine. I'm gonna leave it just in the near future when you're coding and we happen to stumble upon a question that asks us to do that, to set the pixel. And then I'm just going to have method to be delegated, right? That's what I'm just gonna call it. And remember, they said it should return a string. And remember, the string is defined inside its own library. So since it's an object, it's a class, right? So I need to import the string. And then since I'm going to make use of IO stream, I need to import IO stream. And then I need to exit, right? I'm going to use the exit function, blah, 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 when there's errors. So I'm going to include my C standard library, C standard lib. And then I'm going to use a set to make sure that I want to use a session, right? To make sure that I do not change. For example, I do not deallocate when the object is already deallocated, something like that. So I need that C asset because I need the asset function. So this is pretty much what I need. And I'm not going to say using standard namespace. You can do that on your side. I'm not going to do that. So it's going to return a string, which is part of the standard namespace. And then the function should be called draw. And you see, this is why you need to understand the question. Look at what the question says. It says this method will not set, they even highlight it in bold. This function will not set anything. Therefore, it's a const function. So I need to say const here because it shouldn't set anything. That's why they give you that detail, that extra information there. It's all those subtle things that make you lose full marks. So you need to pay attention to what they're trying to tell you. And they even wrote string in bold to tell you, to remind you, listen, this is a string method. It returns a string. They want you to pay attention to that. And then this is talking about Pixel Painter and its subclasses. I do not need that information. So I'm going to scroll down and go to the information that's relevant to UJ image, which is here. Remember, this is all about implementation for the different child classes. I do not need that. And then I need to do operator overloading. So I'm going to skip to T4, add this to your UJ image class. That's why I skipped here. And then an overloaded assignment operator, which performs a deep copy. So there's an assignment operator. So we've overloaded quite a few operators. So I'm going to say operator overloading. And then I'm going to say operator keyword. What operator am I overloading? Remember, it's the assignment, which is the equal sign. You should take in another UJ image that I want to copy from, but then I don't want to take in the whole image by value because it might be too big, right? So I'm going to go to its address instead, or just take in its address. But then when I go to that address, I shouldn't be able to make changes because I just want to copy from. That means I want to copy values. I do not want to change that object I'm copying from. Remember, that's how you make a copy. You just take the original, copy whatever's in the original without changing the original image or original document. So const keyword there. And then I know after performing these changes, I'm going to return a UJ image. But this UJ image, I don't want to return it as by value because that might be too big again. So I need to return it by address, but then I don't want the user to be able to make changes. So therefore, I'm going to say const UJ image reference. And then date full. And then yeah, for the see this one, alignment padding, don't what. We'll get to it when we get there, when we get to file handling. So for now, the only thing that's important to me is UJ image. And then support for the stream, using the stream operator for output. That's the stream insertion. So that's a friend function. Remember, friend functions, what we are told in the textbook, it comes before everything. So I'm going to come here and say over, and then I'm going to go here and say overload the stream insertion operator, right? You need to put the friend keyword to say this is a friend function. And remember, it needs to return an OStream object by reference. Remember, everything that's returned by reference so that we can go to this to save memory and to also to be able to manipulate that value when it's returned. And then it takes two parameters, what's on the left-hand side and what's on the right-hand side. What will be on the left-hand side? Remember, when you do see out, it's like this, right? And then followed by this value, whether it's an object or whatever. What is on the left-hand side? See out is actually like this. It's actually OStream see out. That's how it's declared. That's its data type. And then imagine the right-hand side values of its UJ image. So UJ image value. And then look at the operator in between. It's this operator like this. So that means on the left-hand side, I'm going to have an OStream object. And then on the right-hand side, I'm going to have a UJ image. I hope you can see the pattern here because see out is of type OStream. Value is of type UJ image because I'm creating this operator for UJ image. So that's why I'm putting it in that way. So I'm doing it for UJ image. So hence, like I said, we can assume on the right hand side we have a UJ image, and then that's pretty much why we do that. So I'm going to now pass the parameters. So I know on the left hand side I'm going to have an OStream object or an output stream object. That O stands for output. Remember, we use C out output, right? So OStream object, output stream object. And then it takes in a UJ image, but remember, we only want to display. I do not want to change that image. So therefore, I'm going to take in a UJ image. But remember, you're taking it by value like this, it's costly. It will cost us a lot of space. So I'm going to take it by reference. But then by reference, there's a possibility of me making permanent changes. So I'm going to append the const keyword before it to say, even though you go in there to that address, const prevents you from making any changes. Do not change that object. And then there's our friend function. There we go. And then that's pretty much all we need. Let me just, okay, we're not done. So for double indexing, by the way of an overloaded function invocation operator, which returns a pixel located in a specific row and column. So we need to be able to get a pixel, right? Pixel. And to see which double indexing operator they're talking about, go to the mark sheet. You see, they put in the round brackets. They want the easy one. Not that one where you create UJ row. Not that one. They want the easy one. The one with the round brackets. So I'm going to overload that operator. So I'm going to say, remember they said it should return a UJ pixel. So UJ pixel. And then operator. So this is the only time you only allowed to return something by value when you're told to. They said you should return a pixel. Remember, a pixel is very small. It's just that integer or whatever that value is at that specific row and column. So it's very small. It's not. I'm not returning a whole object, so I don't have to worry about memory. Basically, getting it by address and then put the const. I don't have to worry about that. I just return UJ pixel as is. So what's the operator? It's this operator, and then you put brackets next to that operator to specify what parameters the operator takes in. Remember, we're getting a pixel. It's sort of like get pixel. It's sort of like this method here. So since I have this function here for accessing, it actually becomes irrelevant to have this function here for accessing. I hope you can see that it becomes irrelevant. So I actually do not need this one, but it's fine. We're just going to leave it there because we want to show that we have a lot of understanding. We understand accessors and getters and things like that. Accessors and mutators, I mean, setters and getters, we understand them. So UJ Pixel, like I said, I created my rows to be of type unsigned short, and also my columns of type unsigned short. So therefore, I'm going to take in two values, the row, which is unsigned short, and the column, which is unsigned short. But then remember, this is just meant to access. So I'm going to put a const there. Let me see, they didn't say you should be able to set the pixels. They said you should support for double indexing of an overloaded operator function, invocation operator, which returns the pixel located. Yeah, they said it just returns, right? They didn't say after returning you should be able to change the pixel. They didn't give us all those details. If they did, then I wouldn't put that const at the end. And I would also return it by address. If you remember when we were overloading that double indexing operator, you would have to return it by address and remove this const keyword because you want to actually make changes. So the class is actually now officially complete. Yeah, UJ image is complete. Without the bonus, okay, without the bonus and the alignment padding and fine binary file handling, all these things. Without that, okay, UJ image is okay. UJ image class is full, right? We are done with it. All the other things that are related to file handling, but UJ image itself is done. Then I'm gonna copy here. Remember Pixel Painter, when you go to the CPP file, you need to import the header file because why? You're gonna call the methods within Pixel Painter. That's why. And remember your textbook, it told you that every friend function, when you go to the implementation file, you omit the friend keyword or else it's gonna crash. That's the instructions from the textbook. And then I need to specify which class this function is coming from. It's coming from UJ image. And then I'm going to copy this. And then I'll just leave the comments there, but I don't see the need, but I already had the comments, so it's fine. I'm just gonna leave them there. This is a part of UJ image. And then this is also part of UJ image. Since we're gonna be repeating a lot of constructor code, the code inside the constructor and the code for copying, that's why I created helper methods, because we have the assignment operator. Remember, the assignment operator is basically the copy constructor, but the only difference is that it does a deep copy. Okay, I don't need my class constants this side. I've already declared them. All I need is just to access them. And then right next to the name of the function, I put tell C++ where this function belongs to. It belongs to UJ image. Like I said, some of the accessors are not necessary, just that you're showing them that you know the good design principles, right? And then there's my mutators. So far, I only have one. And then this is the method that needs to be delegated. Okay, I keep forgetting. I must not forget to specify where these functions are coming from. They're coming from UJ image class, and then operator overloading. These are my, okay, I need to take that operator that's there, but it's fine because it's a friend function. Okay, it's a friend function. I made a mistake again. It's a friend function. It's not part of UJ image. So should not be there. I shouldn't specify it's part of UJ image when it's not part of, it's a friend function. Even though it's declared within UJ image, but it's not part of the class. Don't get it confused. But all the other ones are part of UJ image. And then there's this operator. And I think we're gonna need an enforce range. Yeah, we're gonna need an enforce range because remember they said you should This is the semester test. You must show them that you know everything. Just like that TikTok. But show them, baby, show them. Overtake, undertake. That TikTok video. You must show them that you you know. And then after saying show them, baby, they got into an accident. Yeah, ne. Bupilo. Kiki Fatuk. And then I'm going to do this. Quite a lot of things to write. You see, if you need to be fast, I suggest you start practicing how to type fast. You run out of time and fail to get a distinction because you didn't have enough time, even though you knew your code. So I advise you to practice to type fast. If you don't know how to type fast, it's simple. You just go to here and search typing game. It, it's gonna drop letters, right? And then all those letters you type. Yeah, yeah, you can choose any game here. Choose the game, and then it's gonna drop letters. You need to type them. It's sort of like a shooting game where you shoot characters, but you shoot them, but you shoot the characters by typing the word that's on the screen. It will train you how to type fast. And then I need to have an enforce range. So force void and force range, right? And remember, it needs to have a const because it's not meant to really change anything. It's meant to validate the range of my values. And there's three things that it's going to take in. It's going to take in an unsigned integer, like an unsigned short, I mean, three of them, because we're going to take in three values that we are measuring, right? We are checking. So it'll be three unsigned shorts. So the first short, unsigned short, will be the value that we're checking. And then the second unsigned short is the minimum range. The second, the third unsigned short is the maximum range. So like I said, when you're writing this within the header file, you do not necessarily need to give the parameters names. You only give them when you start implementing, therefore in your CPP file. And then since I have an enforce range, I need to have, what is this? Remember, I need to have constants. So I need an enum for my status code, right? So I'm gonna go back here to UJ image and then create another enum. So enum, and then I'm gonna say status code. Was this for my status code? What's the state? Should did or is there an error with something, things like that. So like I said, with enums, they always start at 0, but you can give it a starting point and then the following constants within in that specific order, it's going downwards, it's going to increase by 1, taking the value of the previous constant. So I'm going to start with error in range, right? Because there might be an error in the range. And then what other error can there be? Uh, so there's error in range, and then yeah, I'll add all the errors as we go on because I don't know what other errors are there. So for now, I'm just going to set this to start at -1. Remember, the next constant takes the value of the previous constant and adds 1. So this will just be the value of the previous one -1 plus 1, which is just 0. So that's why I set it to -1. So error in range, that's the constant I'm gonna use. And then is there anything that I need? Okay, there's nothing. So now I need to make use of these values. So I need to give the parameters, so I need to give them names. So this is value, and then this is mean. Do not ever use mean as a variable, right? You see, it's reserved for something else. It's gonna crash. So you could say lower, and then you could say upper. And you see, upper bound is already reserved. Don't use those names. Be very careful. If it highlights in a bold color, that's no, that just know it's reserved. So lower and upper. And then I'm gonna have if statements, right? So if my value that I'm checking happens to be less than the required lower value or the lower range, then we have an issue. So I'm going to output an error message, and then I'm going to say your value that you've entered is less than the required minimum of, and then I display that minimum, what minimum value is required, which is the lower, and then I output an end of line character. So standard end line. So what is the required minimum of? So it should be required minimum of that value. And then I call the exit function to exit my program and use error in range constant. And then it's going to be pretty much the same thing. So I'm going to do another if statement. But then now I'm checking if it's greater than the required maximum, which is the upper bound or upper. And then I just change here to the required maximum of, what's the maximum value? It's upper. It's not lower. And then I need to change this to is greater, because value is now greater than the required maximum. And then I'm done implementing my enforce range. Now let's implement the helper methods, right? So remember, with your helper methods, you pretty much write the same code in the other in the functions of the constructors that code is supposed to be in. So this is a destructor method. That means the code that's supposed to be in the destructor must go here. And then instead of implementing the code to destroy or to free memory, I just call this helper method. I don't have to repeat myself. And then I'm going to use the asset method. I don't know whether it's inside the standard namespace. I'm not sure. The asset method, but I think everything is within the standard namespace. I'm assuming. So I'm just going to put as, let me see if it does show on the list if I do this. So then I said, okay, it doesn't. So I don't think it's in the standard namespace, but as far as I'm concerned, everything within that comes with C++ is within the standard namespace. Even the exit function should be, but let's just leave asset like as it is. So asset, what am I trying to asset? Asset that the underscore pixels, right? It's not equals to null, meaning that it's actually pointing to something. Remember what the asset function does. It simply, in other words, the asset function simply says, make sure. So make sure what pixels is not equals to null or to nothing. If you use your brain and your logic, right? If you're saying something is not equals to nothing, if you're saying this variable is not equals to nothing, what are you saying? You're saying it's equals to something. Remember, there's no keyword called something inside C++. You'd have to use the keyword null pointer and negate that and say it's not equals to null or it's not equals to nothing, which is, it's just English here. So not nothing is basically the same as you negating nothing, which is just the same as something, because there's no something keyword within C++. So I would have to say not nothing, basically not equals to nothing. It's not equals to nothing, meaning it's not nothing, meaning it's something. So it's just terminology here. So I'm just gonna put it there. Once I'm sure that it's equals to something, then I can deallocate. So I'm going to say for unsigned short r is equals to 0, r is less than underscore rows r plus plus. And then I'm going to put curly braces just for the ones that get confused. So I won't use that technique whereby you can, when there's one line within a for loop, you can omit the curly braces. I'll just put them there. So what am I supposed to do? Delete the memory that will be allocated at every single row, right? Remember, when you allocate, you're going to have a row and a columns dimension here, right? To deallocate, we use the delete keyword, and then we leave one of the dimensions empty, like this. But then the syntax for C++ is that this dimension, you need to put it immediately after the keyword delete, like this. And then we still have this dimension for rows. We need to also delete it. So I'm going to delete outside the loop, delete, basically delete like this, right? Set it to empty. You see that it's nothing. Set it to empty. But the syntax for C++ is that the square brackets need to be immediately after the delete keyword. And then if you remember the diagrams that we've been drawing, right? After you've said this thing, you still have access to that memory. So we need to cut that connection. So we set underscore pixels to null. It's equals to null pointer. This is very important here. If you don't do this, your code will just jam and you won't know why. So we put this there so that we get that segmentation fault error, so that we know that we're trying to access a memory location that does not exist. So we are done implementing the helper method for destructor. And then let's do the helper method. We're just starting with helper methods at this point in time. So I'm going to need to take in this object. So I'll call this one obj right hand side, because remember, when is the constructor invoked? The constructor is invoked when you use the equal sign at the same time as you are declaring the object. So when you do this, uj obj, let me tell you obj1, and you say is equals to obj2. In this technique, it calls the constructor, the copy constructor. But if you do it this way, you declare separately and you assign separately, then it calls the assignment operator. This will call the assignment operator. That previous technique where you initialize it and at the same time you're creating it, it's going to call the copy constructor. So just know those differences. So now I'm going to go through all of my rows and columns. Unsigned short r is equals to 0. R is less than. And remember, this one doesn't care how big the object is. It just copies. So it's a shallow copy, because that means we might not copy everything. For example, if I have a glass and then I'm trying to pour 2 liters of Coca-Cola, it's going to overflow, right? It's going to start spilling, right? So that means at some point I'm going to stop and say, okay, this glass is now full. But then the 2 liter still has Coca-Cola in it. That means I haven't copied everything. So hence we call that a shallow copy. You're just lying to yourself that you did copy, but it's actually shallow because you didn't copy everything. And then after going through all of the rows, then I'm going to go through all of the columns. Short c is equals to 0. C is less than obj right hand side. And then C++. And then now we copy. It's simple to copy. Just say underscore pixels at a specific row and column is equals to what? My object's right hand side pixels array at that specific row and column. That's how you copy. And then you're done copying. And then the constructor, it needs to have the number of rows, it needs to have the number of columns, because now I need to use the values within this constructor helper method. So rows, columns, uj pixel, default pixel. Then what I'm going to do is set the rows. So underscore rows is equals to rows from the user. Underscore calls is equals to calls columns from the user. And then underscore pixels. And now we allocate memory for the pixels array is equals to new uj pixel pointer, right? We start by allocating the outermost pointer, and we replace every single pointer with a pair of square brackets, right? And we pass the size of that pointer or that dimension within the square brackets. So I want mine to start with the rows. So I'm going to start with the rows there. Then after I've allocated it to rows, then I go through every single row that I've allocated, right? So unsigned short r is equals to 0. R is less than underscore rows, r plus plus. And then for every single row, so underscore pixels and then square brackets r to index, right, is equals to a new uj pixel. Remember, the first pointer we've already allocated for it, so we can omit that one. Now we are left with this other dimension of this one pointer. Then remember what I said, how to allocate, you replace each pointer with the pair of square brackets. Then within the square brackets, you pass in the size for that pointer or for that dimension. Like I said, each pointer represents a dimension. So replace the star and then with square brackets and then underscore columns. And then the reason why we do this, right? The reason why immediately after setting here, I do an inner for loop. Let me show you why. If we didn't do that, that means remember we need to set the pixels to this. That means I would have to do this, create a separate for loop. And you see that I'm going to repeat myself. Short r is equals to 0, r is less than underscore rows, r plus plus. And then for unsigned, short c is equals to 0. C is less than underscore calls, C plus plus. And then I just set underscore pixels, and that specific row and column coordinate is equals to default pixel. Isn't this loops the same as this thing here? So why am I repeating myself? It's unnecessary. So that's why we just combine everything into one for loop. So that's why I'm gonna come here and say for unsigned short c is equals to 0. C is less than underscore columns C plus plus. And then I set the pixel at every single row and column coordinate to that default pixel that's going to be passed by the user. I hope that makes sense why we have two for loops in this way.
Yeah, it does.
So, yeah, just that I totally forgot to explain it. It just went over my mind. I was starting to become like Dr. Stone, assuming you guys understand. I just totally forgot to do that. Not me throwing blows. Hey,
Mm.
let me keep quiet. Distractor. So this is the distractor, the actual distractor, right? It's the same code that's written in my helper method. So I'm gonna call the helper method called distractor. This does, just know that this is what it does whenever you call a method. It copies and goes to that line where you've called the method and paste the code within that method, like this. So you see that I don't have to repeat myself. I just reuse. So that's why I created helper methods. You see why? Because remember with an assignment operator, you also need to deallocate first, allocate to make sure we are of the same size, and then copy the values. Because I now know, or I am now 100% sure that I'll be able to copy every single value. So that's why I needed the helper methods, because there's a lot of repetition that will go into place. Then I'm going to go back to my constructors, right? Let's go back to our constructors. This default constructor will just do constructor chaining. And constructor chaining is exactly the same as calling a method. It'll just go to that constructor, copy and paste everything that's within that constructor into this constructor, and then replace all those parameters within that constructor with these values that I'm passing. So I'm going to pass here default rows because this is a parameterless constructor, so it takes in nothing. So I have to make use of my own default values. So default rows, default columns, default pixel. And then all it does, it means go to this constructor. Which constructor? The one with 3 parameters. You always chain to the constructor that has all the parameters. Always. Don't chain to this small one, the one with only 2 parameters. Why? If you chain to this one, that means you won't actually initialize your pixels, right? So just you could technically you will, but I know we don't want to work with technical. You need to really understand if you want to work with technical. It will set the pixels, but I don't want to take those chances. I always call the fully parameterized. We say that if the constructor or something or a function has all the parameters, we say it's fully parameterized. So I'm gonna go to the fully parameterized constructor, the one with all the parameters. And then even this parameterized one, I'm going to chain it to that. Okay, that's why I need the bigger monitor, bigger computer, because now my screen is, and if I zoom out, it starts to not be that clear, but I think this size, yeah, this is when I'm zoomed out like this, it's fine. So I need to chain again because I don't want to repeat myself. Remember, the programmers are lazy, very lazy individuals. But then here I have the rows that I'm taking in from the user. So I'm gonna pass those actual rows. And then I have columns that I'm taking from the user, so I'm going to pass those actual columns. But you see that this constructor is only two things, the
Mm.
rows and columns, but it doesn't have the default the pixel. Therefore, I'll just make
Mm.
use of a default pixel. So default pixel. It's pretty much the same thing as this previous one. The only difference is that this parameterized one, it has at least some of the information. It has the rows and columns, but it doesn't take in a pixel, so we work with our own default pixel. And then we go to this fully parameterized one, the one with all the parameters, calls. Then we actually implement that one. That's the only one that's the left, right? There's nothing else to chain it to. So we have to implement it. Remember, I have a helper method. I'm going to use my helper method called constructor, which takes in three parameters. And when you're typing, pay attention to how it's helping you. It's highlighting in blue the parameter that it expects. It expects unsigned short rows. Basically, it expects rows. So I'm going to pass rows. The moment I press the comma, it's going to show me what's the next parameter that's expected. So comma, you see the blue, the highlighting switched from this to this because it knew that, oh, you've passed rows now, or you've passed the first parameter. It expects you to pass an unsigned short called calls. So we're going to pass calls, comma. Now it's expecting a UJ pixel, something of type UJ pixel. And what is this default pixel? Isn't it of type UJ pixel? It is. So I'm going to pass that as the third parameter, default pixel. Like I said, when you call a method, it just goes and copies and pastes what's that code there. So what's going to happen is that it's going to go to this constructor, go into the code, copy and paste, and then replace where the first parameter was used with this actual value here. And then where everywhere where this second parameter was used, replace with these calls. And then everywhere where that third parameter was used, replace with this actual value. That's pretty much what it's going to do. And then we're going to go to our copy constructor, obj right hand side, and then simple, you just call your helper method. It expects you to pass some object of type const uj reference. It matches. So I just pass my object, obj right hand side. And then it's going to go and copy and paste that code that's inside the copy constructor helper method. Where that object has been used, replace it to this actual object here, this one that I'm taking from the user. You could chain, right? You could do chaining here, whatever, but then I feel like if you do chaining, you're actually sort of like cheating because
Mm.
remember the copy constructor, it's meant to be shallow. Do not chain here because if you chain it, that means they'll actually be the same size. That means the assignment operator is of no use. So you get what I'm saying? Leave it like this. I know lecturers will show you that to chain the copy constructor. Don't do that. It beats the whole purpose of it being shallow. Because
I
what
don't
this
agree
what
with
what this does, right? I'll just I'll give you the opportunity to answer. Let me just quickly explain this. If I do this and I say obj right hand side dot underscore rows and obj
mm.
right hand side dot underscore calls, and then I pass in default pixel here, it's still the same thing as an assignment because what's going to happen is going to go to this code, copy and paste it, and then take the object that I'm trying to copy from and set it to be those rows for that object and set it to be those columns for that object. Now the containers are of the same size. So what do you mean by shallow copy? You get what I'm saying? So what do you mean it's a shallow
Mm.
copy when it's actually going to be the same size, when it's actually going to copy everything? So for me, I would just not do that because it beats the whole purpose of it being a shallow copy. It's still going to be a shallow copy because we're going to miss one part. We don't delete the memory first. We just start allocating, but which is technically just deleting. That's so I don't want to chain. I want it to be shallow. So I want it to be like this
Mm.
shallow, and then I know they don't store everything. So you're about to ask something.
No, it's fine.
Okay. And then accessors, this is the easy part. This is free marks here. You just say return your rows underscore rows. Get calls, return underscore calls. Get pixel. Remember, we need to have enforced range. So I'm going to have a specific row and a specific column to retrieve the pixel from. Because remember, it's a 2D array of pixels, basically sort of like a Cartesian plane, where X is represented by row, Y is represented by column. So sort of like a Cartesian plane, 2D, right? So I need to verify the row if it's a valid row. So I need to check it within my range of my rows. So enforce range, that row, that's the value you're trying to check, comma, it expects you to pass a lower bound, which is the minimum expected is 0, because arrays are 0 indexed. And then since I'm counting from 0, I always stop at the number before the actual value. So I'm going to stop at rows -1. Why is that? If you think about it, let me just make a simple example, because for some people, that might not be obvious to everyone. So let's say I want to count from 1. Let's keep it simple, 1 to 3. How many values will I have, and where will I stop counting? I'll start at where will I start counting? Exactly at 1, right? I'll stop at exactly 3. You can think of it in terms of mathematics, right? It's square brackets, meaning it's inclusive. The ranges are inclusive. So 1, 2, 3. You see, I stop at exactly 3. So if I wanted to count exactly 3 numbers, but starting in a different way, I start from 0. I can't stop from it's 3. I can't stop at 3. I can't do that. I always stop at the number before. Let me show you why. So if I stop, and remember it's inclusive. So if I stop at 3, you see that the numbers exceed the numbers that I expected. So 0, 1, 2, 3. How many numbers do I have now? It's 4, which exceeds 3. So therefore, I need to stop at exactly the number before 3, which is 2. So I need to do this. But how did I find 2? If you look at the pattern here, you see this is simple maths. Just that you need to see the pattern. How did I go from 1 to 0? I subtracted 1, so -1. How did I go from 2 to 1? So I subtracted 1. How did I go from 3 to 2? I subtracted 1. So hence I subtract 1. That's pretty much the logic behind it. And then I'm going to enforce the range for my column, starting at 0, underscore calls -1. And then once I've enforced the range, then I know we're good to go, right? Then I know the pixel it exists. I don't want to go outside my Cartesian plane. Remember, I don't want to go beyond the range. So that's why I enforce it. And then I simply return the pixels. So underscore pixels at that specific row and at that specific column. And then done. That's pretty much what you have to do. Then set pixel. So I need to give my parameters names now because I'm gonna use their values. So this will be the pixel that I'm setting it to. It's pretty much the same thing, enforcing the range, pretty much the same thing. But then remember, we need to also enforce the range for pixel. And remember, the UJ pixel is a record structure. So there's red, green, and blue color components, which are between 0 and 255. So we need to enforce every single one of them between that range. And it's inclusive. It's starting at exactly 0 and stopping at exactly 255. It's inclusive. So yeah, it's really annoying, but you have to do it. So after here, I need to enforce pixel dot the red color component to be between 0 and exactly 255. And you could create constants for this, right? See, now that I'm going to repeat myself, these are called magic numbers, right? When you have this, these are called magic numbers. Because why? In the future, you'll be like, what number is this? It seems like it's magic. It just appeared from nowhere. Hence, they're called magic numbers. So we give them meaning by creating constants. So we give them names. So I'm gonna call it static const. That's an integer, right? Let me see. Yeah. So okay, but unsigned short. Let me make it an unsigned short. It'll be minimum pixel I call it mean underscore pixel. What's the minimum pixel intensity? And then static const unsigned short maximum pixel, which is going to be 255. You could write it in full and say mean underscore pixel underscore intensity. You could write that because I feel like that's more, it explains a bit more what the actual constant is. I know it's long. That's why I was avoiding to write it like that, but let me just write it in full so that my code is self-explanatory. So minimum pixel intensity and then maximum max pixel intensity. And then I'm gonna need to repeat it for all. So let me just do this. I don't know why I copied straight. I should have just waited. Copy this, then repeat it two more times. Two more times. So two more times. And then the color component just changes. So this will be now checking green. And this is me now checking blue. And then that's pretty much it. Now you set the pixels. You know the pixels are valid and the ranges for my rows and columns are also valid. So you're being, what's that word? You're being very, yeah, you're overthinking, which is a very good thing because over anxiety and overthinking, it actually gives you supernatural powers because you can check all corner cases. So you're being, yeah, it's the word paranoid. You're being paranoid. When you're being paranoid, it helps you a lot because you overthink and then you end up realizing, oh, so it needs to be very valid. It needs to be 100% accurate. If one of the color components are wrong, therefore there's no way we can set this pixel because it's going to be out of range. So that's why you have to be paranoid and force the ranges. And then I'm going to say underscore pixels at that specific row, at that specific column, set it to that pixel that I'm taking in, which is this pixel over here for that specific row and that specific column. And then you've enforced your range beautifully, no issues. You've enforced it in a paranoid way, which makes it very strict and very accurate. That means by the time it passes and gets to here, we know 100% sure the row and column is valid. The pixels, all of them are valid. Both green, red, and blue color component, they're all valid. So now I need to do my draw, but then remember this is delegation. Before we do delegate, I'm gonna leave it empty. We'll get to that later. So when it comes to assignment operator, right, we avoid the self-assignment. What does that mean? It means that if I have int a is equals to 10, and then I have int b is equals to 10, there's no point in setting a to b when they're exactly the same. Because remember, we're dealing with objects here. They're very big. It can take a lot of time. Okay, we've reduced the time because we're going to the address, but it's still an object, so it's a bit bigger than these normal types. So hence we should avoid reassignment. If they're already the same, then we don't assign. How do we do that? We check by using this keyword, which is a pointer to an address of this current instance. What does this actually mean? So this means if you have, for example, UJ image, obj1, and then you have UJ image, obj2. Remember, I said the way you assign or call the assignment operator is you don't call the equal sign immediately after while you're declaring the object. No, you call it after you've declared the object. So here, like this. So when it's like this, right? What's going on here? Remember, another way of calling this is what? He's saying obj1, okay, obj2, not obj1. obj2 dot operator equals passing that object to. Hence, we've defined our function like this. It's just that this is the more mathematical way that we are used to, right? So hence, you can also use it that way. But the actual way is like this. So if it's in this manner, which object is calling the function? This obj1. So therefore, this is actually pointing to, it's storing the address for obj1. Okay, in full, it's like this, address of. So this keyword is the address of obj1 because in this line of code, this object obj1 is the one that's calling the function. So therefore, this keyword stores the address of this one. If obj2 was the one calling it, then this will be referring to the address of obj2. So as you can see, this keyword, it always points to the current object calling the method. So hence I use that keyword to say whatever whatever object or instance is calling this method, check its address and compare and make sure that it's not equals to the address of this one on the right hand side. So hence this one is going to be called obj right hand side. Compare the addresses and make sure that it's not pointing to the, it's a different location. It's not at the same address as the one on the right hand side. If they're different addresses, then I know the objects do not have the same values. And then at the end of the day, I need to return myself, which is this, basically this current instance or current object. But remember this function, operator function, it expects to return a UJ image. Don't worry about the address of whatever. It gets the address of that UJ image returned. So it doesn't expect to return the actual address. It expects to return the object. So therefore, I need to point to that address or go to that address to get the UJ image or the object. So the flow for making sure that things to assign or to copy values from the object, this object here, into my current object, how do you do that? The flow is simple. You always start by delete whatever is there. Because we need to make sure that we have the same size, right? How do you make sure? I delete first. Delete whatever is there. Make sure that I started on a clean slate. So there's a method for that. You see why we created a helper method to avoid this. Because if I didn't create it, I'd have to say asset underscore pixels not equals to null, and then delete, and then set equals to null point. You see, I'm repeating myself. Because that same code was already defined where here in the constructor and also in the where is it? In the distractor. Where's the distract here? In the distractor. So that's why I created a helper method so that I don't repeat myself because I have an assignment operator. So I'm going to call the distractor method because it's the one that's meant to delete the memory. And then once I've deleted, allocate to be the same size as the object that I'm trying to copy from, which is obj right hand side or obj RHS. So the same as obj RHS. So I'm going to call the constructor method to construct or to allocate memory for my object, but what dimension am I going to use? Dimensions from obj right hand side. So I'm going to say obj right hand side dot rows, obj right hand side dot underscore columns, because I want us to be of the same size. Technically, there's multiple constructors you can call. You can call the one that only takes in the rows and columns, which is fine. Or you can call the one that calls that is three parameters. Either way, that default pixel will be erased. It doesn't matter. So me, since it doesn't matter, I'll just call the one that is two parameters, that constructor. That's the one I'll call. And then it's going to initialize to some default pixel, which doesn't matter because at the end of the day, we're going to override and remove those values. Now we actually copy the values. Where do we do that? Copy constructor. And then I pass the object I'm trying to copy from, which is obj right hand side, which is that object here. And then I'm done. If you understand the flow, it'll be easy to copy. So that's it. You're done copying. It's easy for me. Why? Because I created a helper method. If I didn't do this, I'd have to rewrite everything from scratch. All of the code within every single function here, I would have to rewrite it, which is a problem. Hence, I created a helper methods. So now I can code even faster too. And then this invocation operator, this one is easy because it's an accessor. It's just to get the pixel. So that's basically you're taking a row and a column to get that specific pixel. And remember, to get the pixel, we need to enforce the range first. So I need to say that row needs to be between 0 and what? Underscore rows minus 1. And then enforce range, that column needs to be within the range for my columns. And my columns start from the range 0 up to columns minus 1. Since I'm counting from 0, so I have to count, I have to stop at the number before the actual number of rows and stop at the number before the actual number of columns. And then I return my pixels, just like the accessor. That's why I say this one is easy. And then pretty much done, because it's the same as an accessor. And you are returning by a value because you are not told whether they should do both accessing and mutating. If it was supposed to do both accessing and mutating, then you'd have to return it by address. Remember, we did talk about it in the when I was making videos for the practical solutions, or when you had the practical and operator overloading. In this case, I do not know yet if information comes and says, "Oh, okay, don't just access, also mutate, do both accessing and mutating." Then I'm just gonna come here. It's a small change. Changes to return by address. Go back to my header file, and then make it return by address to here. And then I'll be done. Okay, we are pretty much done with yeah, we're pretty much done with everything. Okay, not everything here. I was like, hey, that was fast, done with everything. And then I'm going to give my parameters names because I want to actually use them. So O just means O stream, and it's going to be on the left-hand side. So LHS. And then the object that I'm trying to print is going to be on the right-hand side. So OBJ right-hand side, or RHS. But after I'm done with everything, I must return the O stream object. So I must return OLHS. And then now, remember, it's supposed to be a P2 image. They didn't tell, you see, this is why, the, this is actually testing whether you're doing your practicals or not. You see, they didn't tell you how the output should look. Let me see, did they tell you? Oh, they did. But they shouldn't have told you. You're supposed to know. And they told you the maximum intensity. You see, by showing you an example, it's 255. So, right. So, as you can see, it depends. Yeah, it depends on the image. So override the draw method to perform. Oh, there's two types of images. This is spiritual. You print it, you can either print a P3, which is I think it's the edge image, or a P2, which is the grayscale image. Yeah, they even give you a hints here. You see, hint: create a duplicate an image which temporarily hold the new values. Okay. Um, let me just double check. Let me think here. Because you need to be able to print the pixels, and I can't print out P2 or whatever. Oh, there's people that want you to think. Yeah, my brain cells are active now. Remember, we store the image type. You might not see the significance of this, but there's a significance. Why? Because remember, when you start here, we always say C out. No, we don't say C out anymore. We use O stream, and we say P3. But then remember, there's two images, P3 or P2. So therefore, I need to do if statements. So I need to say if obj right hand side, right, dot underscore pixels, right. But then remember, underscore pixels is basically a 2D array, so you need to index. It doesn't matter how I'm indexing, to be honest. So I'll just choose a random pixel. I'll just choose at 00. Why am I choosing 00? Because I want to get the image type. That's the main important thing. I don't care about the row and column. So I want to say dot type, dot type. If type is equals to gray scale, and then I print using P2. I know you've never seen this. This paper is not playing around. You need to use your brains here. Hence, they give you past papers to practice. So pixels, I choose that same random, and then dot type. Why am I saying dot type? Remember the pixels array. It's a struct. So I can use the dot notation again to access within that record structure. Dot type is equals to edge, right? If it's an edge, then it's a P3 image. If you're not sure whether which one is P3, which one is P2, they did tell you here an edge painter. You see under edge painter, they said it should return a P3 image. And then, okay, I see. These people are smart. There's another way to do it. Because I'm gonna repeat myself. There's another way to, a very intelligent way to do it. And then the grayscale is P2. There's another way to do it, an intelligent way. Remember, this is going to be checked within that string method. This one, the draw method. Remember, the draw method is basically the 2 ppm function. So I'm basically going to do the same thing that I'm about to write right now. So why don't I just write it within this this draw method? And then here, all I simply do is, I say O left hand side, and then insert into the stream whatever is returned by that draw method, like this, and then return the O stream, which is very short, right? I don't want to repeat myself. I'll show you why I agree that this is fine, because you realize that this method here will either return a string for a P2 or a P3 image. So it will either have something like this. We're gonna have a string stream, right? So SS, and then you're gonna have whether it's P, if it's edge type, it's P3. If it's the other one, gray type, it's P2. It's going to return that string, right? So that's why when I came here, it's actually simple. I just do this. And then I could, if I wanted to just put an end of line character. It's not necessary. I'm just being fancy here. Just put that end of line character. You don't have to, but this is the only thing that you needed here. I think they're testing whether you understand your code or not, because it's actually simple to draw if you have that draw method, which is basically the 2 ppm function. They've used a different name for it to try and confuse you. So yeah, that's all you had to do. I was like, okay, I'm about to retype and do all those things. Then now we need to do delegation, right? So before we do that, remember how delegation works. So remember Pixel Painter, it needs to have that draw method. And they didn't tell you what the draw method should take, blah, blah, blah. Let's see. The integer variable row and column to represent integer integer variables to represent the size, blah, blah, blah. A row to the pixels, blah, 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 multiply. This is now actually the code. And then overrides the method to perform. The method does not alter the actual pixels in the image. You see, it's not meant to alter. It's just meant to return the P3 image string. That's all that draw method does. That's literally all it does. So, which is fine. So what I'm going to do is I need Pixel Painter, right? So Pixel Painter is an abstract base class containing this, blah, blah, blah. They didn't tell you what the draw method function actually takes in. But if you remember your practicals, we need the UJ image instance to be passed to that draw method. So I'm gonna go to my painter class, right? Pixel Painter class Pixel Painter, right? And then public method. And they told you that that function should be a pure virtual function. You see, the string returning function should be a pure virtual function called draw. So by pure virtual, and remember, okay, remember there's a different header file. There's no inheritance here, right? So, and UJ image, to avoid circular dependency issues, I'm just gonna do forward declaration for UJ image here, blah, 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 and then include the header file within the CPP. So with that being said, that means I'm actually okay. Eventually, I'll import, but C++ is very confused, right? It gets confused easily. So it's fine. I'll import the string again here. Even though when I import UJ image, it's already part of UJ image.h. You see, it's already part of here, but it might not pick it up. So I just have to include it again. But I don't like secular, including header files over and over. Let's see if it won't complain. Let's not. Okay, it will, yeah. I'm thinking about it, it will. And then I'm gonna need IOStream again. Yeah, that's C++. It's really annoying. So I'm going to say standard. So that function should return a standard string, a string basically in the standard namespace called draw. But I need to take in what the UJ image that I'm going to draw from, right? So I need to get the columns and rows for that image and things like that. So therefore, I need to pass in a UJ image. But remember, you passing things by their value objects, they're too big. You pass them by address. If you do not want to make any changes, you put that keyword const. Then if you check here, they told you that where's this code? Yeah, the method does not alter the actual pixels in the UJ image. It doesn't alter. So it needs to have that const at the end here because it's not changing anything. But then they said it should be a virtual function. So I'm going to put the virtual keyword here. It's quite a nasty, long way of declaring it. But you see that I'm understanding it in bits and pieces and adding as I go along. So virtual, but then they said it's pure virtual, meaning that I shouldn't implement it here. So I need to say is equals to 0. This now makes it pure virtual, meaning that I won't be, it's going to force every descendant or every child class who inherits from Pixel Painter to implement it. It's a must. But if I had left it as just virtual like this, it's optional to override this function or to implement this function. It's optional. Now it's no longer optional, it's mandatory because it's now a pure virtual function. Therefore, when it now has a pure virtual function, this now makes this class abstract. Abstract meaning that it's in or incomplete, which is true because this method does not provide any implementation. So it's incomplete. There's methods or something missing that is missing code. That is no code. So there's missing code. And then for the sake of inheritance, because this will act as the base class, if you read continuously, but to get there, you see that Edge Painter is a kind of pixel painter. That means Edge Painter will be they even tell you an abstract base class. So I know it's going to be a base class. So everything that was supposed to be private should be protected. So here, that's when we pass all the things that should be protected. And then since I now have this method defined, the draw method, now I can go to VJ image to call it. How do you call it? Remember, I have underscore pixels, not pixels. What is this? Painter, underscore painter. There's that object, right? But remember, it's a pointer. So I need to dereference to go to get the actual pixel painter. And then I've now have the painter. So I need to put round brackets here and say dot to access that draw method. Because now I have dereferenced and gotten the pixel painter. I want to access the draw method. So access the draw method, but it expects me to pass a UJ image. You see that, remember what that address of means. It means the actual object, when it's passed, it will go get its address. So you don't pass an address when you pass here, you pass the actual object. So it expects a UJ image. So in order for this to work for every single instance, I must use this keyword. But remember, this keyword is a pointer. So I'm actually passing an address, which is wrong. The draw function expects me not to pass an address. So I need to pass the object. So I need to dereference and go to this current instance. But then this, you see, this syntax is very spiritual, the syntax. It's a very cryptic. We can sort of somewhat make it better. So whenever you have a pointer, when you dereference and you have a dot, you can replace those two things with an arrow like this. So you can say, oh, come on, you can say this minus and then a greater than sign. You see, it accesses doing the same thing, but the syntax is a bit better now. So you see, it's a bit better. It's not too bad now. And then now this is where we do the actual delegation. Make sure you put comments. Remember, there's 3% for comments. And comment everywhere where you delegated. But remember, we are not done. Before I forget, this is a very important thing, or else you have what we call dangling pointers. Remember, this needs to be managed, its memory. And if you check the document, I'm sure it says that when the UJ image is allocated, you must also allocate that object. So I'm going to come here to my constructor helper method because all the other functions, they call these helper methods. So I'm going to implement within the helper method. So here I'm going to say lifecycle management. So put comments there to make it easy for assistants to see your code. So I'm going to say underscore painter and allocate a new paint painter what? Pixel painter. Pixel painter. Like this. And this will call the default constructor. So if it's not defined, we're going to have an issue. You have to define it. So I'm forced to come here and define a default constructor. So default constructor or a no args constructor. So this will allocate memory on the heap and returns an address, right? And remember, a pointer, when it's used without the star, it's actually referring to the address. So hence, that's why this works. Because this is meant to store an address. But whenever the new keyword is used, it allocates the object or memory on the heap, and then it returns the address of where that object is on the heap. And then we store that address into a pointer. Hence, we created it as a pointer since we are managing the life cycle. So I hope that makes sense. And then I'm going to go to my destructor code. And then I'm also going to have the comment life cycle management. So I'm going to delete, right? So remember, this is not an array, it's an object. So I'm just going to delete the memory allocated for painter like this, right? After I've deleted that memory, I make it point to now so that we don't mistakenly try to redirect to that specific memory when it's no longer allocated because you've deleted that memory. And then that's it. You've done lifecycle management. You've done a lot of things, to be honest. Even though you might not have implemented everything, but you've done a lot. So there's the delegation. We've delegated, and then we've implemented all the operators. So you can get your full marks now. Let's kind of calculate because I think I should end the session now. So you can kind of calculate the marks. Let's sort of like imagine how many marks we have. So I have this 10%, right? And then I did use the header files and CP files. So let's say just get the three. Let's assume you get the three, even though you're not done with all the classes. So you get 3%. So that's 18%. Commenting automatic, you already have the full marks. So that you're sitting at 15% now. You did create distractors. Constructors, I mean, did create all of this. Information hiding. That's when you do it's the same thing as like about private and what all those things and separating putting a header file and a CSV file, that's also class, it's also technically information hiding. We did that. So let's just assume you got full marks here. So you're currently sitting around 30%. Life cycle management, those parts 5%, we're sitting at 35% now. Create contain class, I don't know. You see, composition and delegation. It's so we have the full 20. So I'm sitting at 50% right now as we speak. I'm sitting at 50% right now as we speak. So you see how easy it is to pass. But then 50, remember we overloaded these operators. 50 plus 15, I'm sitting at 65%. And then abstract base class, we might not get all the full marks, but you see I've already passed. And then member visibility, see this one? This means you use protected. That's what it means. Did I use protected? Yes. So you see, I'm around 70%, 65 to 70% so far without doing a lot of things. And I haven't included bonus. If I do bonus, you see that now I'm already 90 something percent without answering even file handling. I can just keep file handling and then make it up by doing templates. I could do that if you forgot file handling. So you can get 100% in this paper. if you practice and do all the past papers and you know which sections are being marked. So you see, I've already I know that I have at least 50% so far. And did I write anything meaningful? It's not a lot, it's a lot of code, right? I agree, but it's not like really a lot. It's not like the main core problem of the practical. So even if you fail to understand the logic for the practical, you've already passed. So yeah, that's it. We'll continue tomorrow. I know there was quite a handful of information and a lot of things involved. I'll only upload or give you this solution once we are done with the paper. I want to give it to you
Uh,
in bits and pieces.
can you please upload it because I got lost somewhere. I was busy with something.
Okay, it's fine. I won't upload. I'll just send it in the group.
Yeah.
When I officially upload on YouTube under the description, it's when I'm done with everything. It's fine. I can
Oh,
just send you the every time
yeah.
after the session
Mm.
in the group chat. But when I upload, when I actually put the links on each of the description of the videos, that's when I'm done with the full past paper.
Mm, mm,
Yeah, so let me stop recording. Okay, so it's around 2 hours, 9 minutes. Yo,
mm.
Yo, I'm tired.